What's up, guys? Today I'm going to be talking to you about logarithms. So I want you to think 2 to what power equals 8? So because 2 to the third power is 8, that means that x is equal to 3. Pause the video and come right on back. So in your head, you should have thought 3 to what power gives me 81? And then finally, 3 to the fourth power would give me 81. So that x is equal to 4. A logarithm is the inverse of an exponential function. We would read this as y equals log base b of x. Here's from exponential form to logarithmic form. Notice how these b's, these bases, are exactly the same. Notice how I wrote the 3 in pink, just like I did the b up here. I wrote the 4 in black, just like I did the x up here. And I wrote the 81 in green, just like I did the c up here. I'm going to go in one big circle. First, I'm going to write log. Remember that the bases are the same. So I would say log base b, or in this case, log base 3. Always start with the base. The base is the place where we want to start our problem. So here we go. I'm going to go in a counterclockwise circle from 3 to 81. Okay? So see how the c value over here in green is the same as this c value over here in green. So that means I'm going to do log base 3 of 81. I'm going to write that in green. I'm going to keep going in that counterclockwise circle. 4. Start with the base to 81 to 4. I'm just going to write mine over here. Go ahead and pause the screen. I'm going to start log base 7. I'm going to go in one big circle of 343 equals 3. Same thing here. Start with the base. Log base 8, big circle, of 64 equals, finish the circle, 2. One more time. Log base 4, one big circle, of 4, finish the circle, equals 1. Okay, so now we're going to do the exact opposite. We're going to go from logarithmic form back to exponential. I'm going to write log base in pink of 16 in green equals 2. I can do the exact same process. Start with the base. The base is the place where you want to start your problem. So start with the base, 4, and do the same thing. Go in one big circle. 4 to the second, finish up the circle, equals 16. These are actually easier to check because it makes sense. 4 to the second power is 16. Okay, so here are some for you to try, and pause. Come back when you're done. 10 to the third equals, finish up the circle, 1,000. Start at the base. 2. 2 to the negative 5 power, finish up the circle, equals 1 over 32. Start with the base. 8 to the second equals, finish up the circle, 64. All of these make sense. 10 to the third power is 1,000. 8 to the second power is 64. You might not remember, but when you have a negative exponent, remember, negative exponents are very sad because they don't like where they live. So 2 to the negative 5 is in the numerator. It doesn't like where it lives. So once we send 2 to the negative 5 to the denominator, that exponent becomes positive because now it's happy where it lives. It was afraid of heights. Now it's happy in the dungeons. 2 to the fifth power is equivalent to 32. So there you go. Okay, so if you're taking my Algebra 2 honors class with me, you guys are going to use this information for R.1 and R.3 in IXL. You're going to need to know common logs and natural logs, so I'm saving that for last. So you got to hang on. So we have our first example here for finding the value. You've got log base 5 of 125. For right now, the only way we know how to do that is by changing this into exponential form. So I'm going to take the base and start there. So 5 to the we don't know power. So I'm just going to use an x. 5 to what power gives me 125. Notice how I'm still going in that circular motion. The base to an unknown power is 125. And 5 to the third power is 125. So because 5 to the third power is 125, I could either think of this as that's my unknown, so I'm going to put my 3 right here, or I could change this back into log form. Log base 5 of 125 equals 3. Log base 2 of 256. Jeez, that's a big number. we can just convert it into exponential form and kind of guess and check for now. Eventually you're gonna get to numbers where you can't guess and check, but that'll be for the next unit. I'm gonna start here. 2 to what power gives me 256? I'm gonna try in my calculator. 16, okay, not even close. 2 to the 8th power. Oh, look at that. I just randomly guessed 2 to the 8th power, and it is 256. Since 2 to the 8th power equals 256, that means that the log base 2 of 256 is 8. Again, I could think of that as changing that back into log form, or I could say this was originally my unknown, so I can put my answer up there. Here's some tries. Go ahead and pause the video, try them on your own, and then come back to me. These parentheses are not 100% necessary, but normally when these get a little bit more complicated, you'll see parentheses around this part right here. I don't have parentheses around here, but I could if I wanted to. I could put that piece in parentheses. This is a fraction here, right? So that means that my exponent must be negative. We talked about this a little while ago. Remember how we talked about how 2 to the negative 5 is a fraction because the negative tells us that it's unhappy, so most of the denominator. Since we have 3 to some power equals a fraction, that means that my exponent must be negative. That 3 to the 4th power is 81. So that must mean that 3 to the negative 4th power is 1 over 81. Means that this up here is negative 4. Had a whole number becomes a fraction, I used a negative. You can think of the exact opposite when you're looking at a fraction becoming a whole number. 4 would need to come to the numerator. So I would have to have a negative exponent here as well. So I'm going to type in my calculator 1/4 to the negative 1, because that's just going to give me a positive 4. A negative exponent changes this fraction into a whole number. 1/4 to the negative 2. And I get 16, yay! So if I'm trying to change that fraction into a whole number or a whole number into a fraction, I'm probably gonna have a negative exponent. 1/4 to the negative 2 is gonna give me 16. I checked that in my calculator. I can also do that by hand. I know that this is equal to negative 2. If you are doing this during quarantine with my Algebra 2 honors class, this is a great section to look at for R.4 in your IXL assignments. But again, you need to know what common logs are before you go ahead and do R.4 in IXL. Okay, so now we're going to be talking about common logs, which is just log of x. Now, when you don't see a base, you assume that it's log base 10. When I look at log of x and I don't see a base, that it is base 10. If you look on your calculator, you should have a log button somewhere on here. This is a TI-89. So I actually have to hit this diamond and then 7, and see it'll show log right there. This log that's on your calculator is log base 10, or the common log. Next up is our natural log. That's lnx. Natural log of x is how you would say that. You remember the natural base e if you did interest problems like a equals p times e to the rt? Base e is a irrational number, kind of like pi. Natural log of x is this, log base e of x. But this is not the right way to write it. This right here is the correct way to write it. When you see natural log of x, you assume that it is base e. You also have this button on your calculator, ln. If I hit second and then that x button there, I should see natural log on my calculator. Now, this natural log of 9, this answer here is estimated. So this squiggly equal sign is natural log of 9 is about equal to 2.197. I can do this the exact same way. Remember that this is base e. It's the natural base e. This invisible e here to the 2.197 is equal to, finish the circle, 9. Now, if you put that in your calculator, you're not going to get that exact answer. So I typed in e to the, I'm going to put in 2.197. I get 8.99798. That's pretty close to 9. So I'm actually going to change that equal sign there to an about equal to. Remember, log with no base, we assume that that's the common log. Start with my base 10, that invisible base right here. 10 raised to the second power is equal to, finish the circle, 100. If you're in my class, again, this one is good for R.2, and then the rest of them where I told you needed to know common logs and natural logs. So, remember when I said that log and natural log are both on your calculator? They ask you to find this logarithmic expression to the nearest thousandth. They want you to just pop this straight into your calculator. For those of you that have a TI-83 or 84, it's going to be close to wherever your natural log is. I'm going to look at my first one, log of 321. I'm just going to type in 321 next to that log there. So I see 2.506. Now the thousandth, remember that's tenths, hundredths, thousandths. So I have to round this 6 up because 5 or more, let it soar. So my answer here is about 2.507. 7 to the nearest thousandth. And for natural log, now I'm going to use the LN button. Natural log of 1,215 and hit enter, and I get 7.1025. So that's going to be 7.103. Remember that we're going to be rounding. I'm just going to use the same set of directions here. So remember that you're using the squiggly line because it's about equal to. Oh. Okay, so we should have seen in our calculator that log of 900, that 2 after that first 4 is 5 or less. So we're going to let that number rest. It'll be 2.954. Now you might have noticed that I put an equal sign here. That's because when I plug in the natural log of 1 into my calculator, I actually get 0. We're going to show why that works on the next page. Natural log of 1 equal to 0. For those of you who are taking my class, my Algebra 2 honors during quarantine, these notes are going to be good for R.5 in your IXL assignments. So the first one is log base b of 1 is 0. That's because any number raised to the 0 power is 1. You should have learned that back in Algebra 1. So for example, 1,000 raised to the 0 power is 1. Miss Valdez raised to the 0 power is also 1. 4 raised to the 0 power is 1, and so on. Any number raised to the 0 power is 1. So if we were to switch this back around, b to the 0 power is 1. Remember, we could go in one big circle. B to the 0 power is equal to 1. That means anytime you have a 1 right here, your answer is going to be 0. Log base 4 of 1 is going to be equal to 0 because 4 to what power is 1? 4 to the 0 power is 1. Log base 1,000 of 1 is going to be 0 because 1,000 to the 0 power is equal to 1. Let's look at the second one. Log base b of itself is equal to 1. That's because any number raised to the first power is equal to itself. For example, 3 raised to the first power, well, that's 3. 10 raised to the first power is 10. Valdez raised to the first power is Valdez. Log base 3 of 3. This kind of cancels each other out. 3 to what power gives me 3? 1. Log of 10. Remember that when we don't see a base, this is what we call a common log. So 10 to what power gives me 10? 1. You might not need this information yet, but I know that my kiddos are going to need this information for their IXL assignments. So anytime you've got an exponent on this inside part here, you can actually pop that over and bring that to the front. A times log base b of b. So I can assume that this is equal to 1. B to what power gives me b? 1. This part right here is equal to 1, and k times 1 is just k. That's why my answer up here is k. For example, what if I had log base 9 of 9 to the second? I can bring this 2 to the front. 2 times log base 9 of 9. So because this is 1, 2 times 1 is 2. My answer is 2. Try this on your own. So some of you guys might have figured out this trick already. That x is going to come forward. Log base 7 of 7 is 1. So that just leaves me with x times log base 7 of 7. So x times 1 is just x. All right, so remember that this natural log is base e. So e to what power gives me the same thing? E, 1. You can even try that in your calculator. The natural log of e, yours might not prompt you to put in an exponent, but mine does, so I'm just going to put a 1 there. is 1. Stay social distancing. Do your homework. Bye.